Welcome, friends, to the Boiler Room Detective channel. If you enjoy these videos, please like and subscribe to the channel. This case is the case of the tardy two-pipe system. There is an old saying, a watched pot never boils. I believe a better metaphor for having patience is to guess the time it takes for a two-pipe hydronic system to change from heating to cooling. The engineer called about a project and asked to meet at the job site. It was a school building that had a two-pipe heating and cooling system. Hot water was pumped through the pipes in the winter and chilled water in the summer. If you've worked on these systems, you know they're a headache during the shorter times of the year. The building may need heat in the morning and cooling in the afternoon. A two-pipe system does not quickly change over from heating to cooling. This is because the lowest temperature a non-condensing boiler should operate is 140 degrees Fahrenheit, while the chiller can handle water temperatures no higher than 90 degrees Fahrenheit. It may take several hours or even a day before the loop cools enough to perform the changeover to cooling. In the meantime, the maintenance department is getting comfort complaints. The owner wanted a system that could switch from heating to cooling faster. In these applications, I typically recommend a hybrid hydronic system consisting of one or more condensing and one or more non-condensing boilers. I would have the condensing boilers as the lead during the shorter periods because they can handle and excel at cooler temperatures. When the loop temperature is between 90 and 140 degrees, the condensing boilers will be the lead and the non-condensing the lag boilers. Once the loop was above 140, I would switch to lead and lag boilers. In this building, condensing boilers were not a cost-effective alternative as the boiler room was 2 stories underground. The extra price for condensing boilers over standard boilers and the cost to install new flues required for the condensing boilers made the project too expensive. I mentally ran different scenarios in my mind and came up with an idea I thought would work. We used 3 boilers for this project. 2 of the boilers were combination boilers with an internal copper coil. The copper coils were typically used for domestic hot water so they could handle the cooler temperatures. The control strategy was to have the heating water for the system go through the internal coils when the loop temperature was below 140 degrees Fahrenheit. Above 140 degrees, the heating water went through the boiler. We programmed the reset control to go from 180 degrees to 90 degrees Fahrenheit when the outside temperature went from 0 to 60 degrees. When the outside temperature was 0, the hot water temperature will be 180 degrees. When the outside temperature reached 60, the hot water temperature was 90 degrees. This project worked perfectly, and the owner got a more efficient heating system and a faster changeover from heating to cooling and back, typically less than an hour. Sometimes you have to think outside the box. If you would like to contact me, my contact information is here. In addition, I have 2 websites. BrewingWithSteam.com is focused on steam systems for breweries and distilleries. It includes a monthly blog about steam issues inside a brewery. My other site is FireIceHeat.com. It is my company's website and shows some of our capabilities. I have authored 11 books which are available on Amazon on boilers. My technical articles are included in these industry publications. Thanks for stopping by Boiler Room Detective